In this part of the praxis, we will look at demonstrating an equivalence of rational numbers. Again, we know that rational numbers are the ratio of two integers a over b, where b is not 0. Therefore, 3/4, 7/5, -2/3, -3 or -3 over 1, 2 or 2 over 1, 0, because that's 0 over 1, are all rational numbers. We have seen that fractions are equivalent if they represent the same rational number. We have a mathematical definition that says two fractions, a over b and c over d, are equivalent or equal if and only if a times d is equal to b times c. Another way to look at this is a over b is equal to c over d if and only if a times d is equal to b times c. We know that 1/4 is equivalent to 2/8, and we often show that by multiplying the numerator and denominator of 1/4 by 2 to get to 2/8. Another way we could show that is using the definition above. 1/4 is equivalent to 2/8 because 1 times 8, which is 8, is the same as 4 times 2. Another way we can represent this is using an area model. In this figure we have 4 equal-sized pieces and we have 1/4. Over here we took the same whole and split it into 8 equal-sized pieces. To represent the same area as 1/4, we would need 2 out of those 8 pieces. Again, we know fractions are equivalent by multiplying the numerator and denominator by the same non-zero number. Therefore, 1/4 is equivalent to 3/12 because we can multiply numerator and denominator by 3. We saw again that equivalent fractions represent the same quantity. So 2/5 are taking our whole and breaking it into 5 equal-sized pieces and shading 2 is equivalent to taking our whole, breaking it into 10 equal-sized pieces and shading 4 of them. We can see this idea of equivalent fractions. We know that 2/5 is equivalent to 4/10 by multiplying both numerator and denominator by 2. 2/5 is also equivalent to 6/15 because we multiplied numerator and denominator by 3. Equivalent fractions, since they represent the same rational number, can be placed on the number line. Here we see 2/5 in its equivalent form, and we know that 1/4 is less than 2/5, and we can also write its many equivalent forms. Fractions can also be expressed in their decimal form. Therefore, we can see that what we would call 0.13 is really read 13/100 because we can actually write it as 13 over 100, or read as 13/100. Likewise, our decimal, which we often read as 0.027 or 0.027, is really representing a decimal with a thousandths in the place value. Therefore, we read this as 27 thousandths, and we can write it 27 over 1,000. Finally, we can look really quickly at mixed numbers and express them as improper fractions. Mixed numbers are those that have that whole number or that integer part and that fraction. We know that 2 3/5 is really 2 plus 3/5, and 2 is really 10/5. And we can add our fractions. 10/5 plus 3/5 gives 13/5. A shortcut to that, as we might know, is we're going to take 5 times 2, which is 10, and add 3 to get to 13/5. An improper fraction is just one of those fractions where the denominator is greater than the numerator in a positive fraction. We can also write 2 3/5 in decimal form. 3/5 is equivalent to 6/10, and 6/10 is 0.6. Therefore, 2 3/5 is 2.6.